Spark is okay so fast when compared to other technologies. What are the different features of Spark? We understood, okay, and we started with the architecture part also. We understood what are the different key components in Spark architecture. So these key components can be separated by programming, by libraries, by management, okay, resource management, by storage. Okay, so if you see, Spark can support all these different components, okay, in components. So okay, there we stopped actually. So today we'll be working on the next topics in Spark. Okay. So before we start, any questions?
Sir, how is it different from this NiFi, sir? Is it Spark? Is it
No, NiFi is just an ingestion tool. Okay. You take NiFi. Okay. You have some data here. Okay. And okay, you bring it here. Okay. So this is the source. Okay. This is the destination. Okay. So
yes.
in between, okay, you have NiFi. So NiFi is a tool which can get the data from
Source to destination.
Source to destination. That's it. Okay. It is not doing any processing. It is just ingesting the data from one source to one destination. Okay. Understood.
Yeah. Okay.
Okay. It is not doing any data validation. Is it doing data validation?
So it's doing a data copy. Okay.
In some time, okay, so I will explain, okay, what is data processing clearly. Data, what is data transformation? Everything I'll explain clearly. Okay. So okay, Spark use case, so that you will understand. Okay. It is just okay. So here, okay, if it is ABC, so here also it is ABC only. It is not okay. It is just okay, copying data from source to destination.
Okay.
My point. Okay.
Okay.
So, but the Spark is not like that. So when Spark takes the data, okay, so it can do multiple things, different things actually. Okay. What are those? We'll see. Okay. And okay, you understood yesterday, right? Okay, so what is the difference between okay, standalone processing, distributed processing, and Spark processing? Okay, when compared to all other processing, Spark processing will be much faster because okay, when it comes to Spark job, okay, so when you launch the job, Spark job, okay, so you will have drivers and driver and executors. Okay, so these driver and executors will be launched, okay, for the first time, and they will be up and running until you stop the Spark job. Okay, there is no end of Spark job. Okay, end means okay, we are stopping the Spark job. That is the end of Spark job. Okay, it is of course it is the same case for Storm job also. There is no end for Storm job until you stop it. Okay, it will be up and running. Okay, but that is not the case okay, with the normal MR job. Understand? Normal map reduce job. Okay, if you start normal map reduce job, it will start the job. Okay, and it will execute something. Okay, finally once okay, the output is generated, the job will be stopped. Correct. Okay.
Yes.
Sir, but as you explained, right, sir, if you go above, if you scroll a little bit above, so on the job 2 it says 1 minute, right, over here in the Spark processing.
Yes.
So here we are launching the executor JVM, so that's 0 minutes because it's already there, and load data into executor JVMs is also 0. But here, if it is, that is only possible for the same type of job or the same type of data, right? But if it's going on the new data, then okay. So for the new data, it's still going to take some time.
Okay, I'll tell you one example, sir. Okay, let's say you have some data. Okay, you have some data. Okay, you are running a job means okay, on top of the data only you will run a job, right?
Yeah.
Okay, using a job, okay, you will not always change your data, right? Mostly for a job, okay, input data will be small. I'll give you one example, sir. Okay, you take credit card table, sir. Okay, you take credit card table. Okay, so first, okay, you load all the credit card table into Spark job, Spark executors. Okay, then whoever want a credit card information, okay, they will send a request to the Spark driver. Okay, Spark driver will pick the data from memory and reply to them. You got it?
Got it, sir. So as long as the processing is happening on the credit card data, it does not need to load the new data at all.
Exactly.
But
It
if
doesn't
let's say the processing is happening on, let's say on the debit card data, let's say, just as an example, so then it has to load the debit card data into it.
yeah, correct.
Okay, got it, sir. So the processing, I understand.
Yeah. Okay. Now, okay, so let's talk about resilience data. RDD set, resilient distributed data set. Okay. What is RDD here? What is RDD? RDD is the fundamental data structure of Spark. Okay. So formally, RDD is a read-only, fault-tolerant, partition collection of records that can be operated in parallel. Okay. So what is RDD here? RDD is a read-only partition collection of records. Okay, let us take this scenario, guys. Okay, let's say this is my Hadoop cluster. Okay, it is already there. Okay. Okay. I'm just giving the existing example. Okay, so this is the example. So now this is the MapReduce programming. Okay, so this is the resource manager. Okay, and these are the data nodes. Okay, data nodes are node managers. Okay, now you started mapper one here. This is the mapper one. Okay, so think that mapper one on block one. Okay, mapper one on block one and mapper two on block two. Okay, mapper two on block two. Okay. Okay. Now, so what mapper one will do? Mapper one will generate one output. Okay, output to local file system. Okay, and mapper two will generate one output to local file system. Okay, and these two outputs are the input for reducer. Okay, and reducer will generate one output to reducer output will be stored into HDFS. Okay, so this is the application master. Okay, which is the first JVM which will start when you run a MapReduce programming. Okay, after that you have mapper one, mapper two, and reducer one. Okay, so mapper one, mapper two mappers and one reducer. Think like this. Okay, so this is the MapReduce programming. When you submit a job, first it will start application master, then application master will contact name node and get the block locations and then convert the blocks to the splits. Okay, and so finally launch on mappers. Okay, so each mapper will generate it output to local file system of this node manager. So once the mapper work is completed, then the reducers will start. Okay, reducers will start. Okay, so what reducers will do? Reducers will take the mapper's output as input and do the consolidation, and finally it will generate the output and store it to HDFS. Okay, this is the MapReduce programming. Okay, but when it comes to Spark programming, how it works? Okay, we will see that. Okay, you say this, sir. Okay, so let's say when it comes to Spark processing or Spark programming, okay, so you are starting the Spark program. When you start Spark program, the thing is that it will start the driver program. Okay, what the driver will do? Driver will launch the executors. Okay, let's say executor 1 is launched here, executor 2 is launched here. Okay, executor 2 is launched here. Okay, so now, so if you see here, so there are credit card, there is a credit card table which is of let's say 250 MB. Okay, so which is divided into two blocks, block 1 and block 2. Okay, so maybe so in block 1 we have 1 lakh credit cards information. In block 2, so 90,000 credit cards information we have. Total 1,90,000 credit cards information I have. Okay, so now what driver is doing? Okay, so driver is launching two executors, executor 1 and executor 2, and it is loading this data into executors. Okay, maybe it is loading. Okay, so total 1,90,000, right? Okay, so 95,000 is here and 95,000 credit cards information here. Okay, so this data will be here only. Okay, now data is loaded inside RDD. Sorry, inside the executor. Yes or no? Okay, so now driver is up and running. Two executors are up and running. Inside each executor, okay, I have 95,000 credit card information, credit card records, and here also 95,000 credit card records. Okay, so now, okay, so let's say there's a swiping machine. Okay, when swiping machine is whenever somebody insert the card into swiping machine, the swiping machine will send a request to this driver. Okay, what this driver will do? Will it load the data? Will it load the data? Huh? Already data is loaded and available in the executors, correct or not? Okay, so driver will just simply give this task to both executors. Okay, now whichever executor is having that credit card information, it will reply to driver, driver will reply to swiping machine. Understood? But okay, if you see the same case, okay, in case of if you go with MapReduce programming, okay, every time swiping machine will launch one new application master. That new application master will launch mappers, load the blocks into it, then okay, write the output into local file system. From here, okay, again, reducers will load the output into its memory. Okay, finally, it write the output. Yes or no? So in case of MapReduce program, if I use the same program, okay, in case of MapReduce, if I use the same program, okay, so if there is a swiping machine trying to extract the data, okay, the swiping machine is trying to extract data. Every time, okay, there won't be any application master up and running here. Correct or not? Correct or not, guys? So every time, okay, you launch a job, okay, it has to start with application master. First it will launch application master, then okay, application master will launch, okay, will mappers, okay, then this table data, the same table data if you take, okay, so credit card table, okay, if you take the same table, okay, so this is the block 1 and block 2. So the difference is, okay, every time, okay, you need to launch application master will launch mappers will load these 2 blocks data into the one storage, then okay, generate the output, okay, so that will give to reducer, finally you will get the output. Okay, so this is how it works. Understand? Maybe okay, reducer may give it back to swiping machine. Okay, so this is how it works. This is the MapReduce programming, okay, which will take a lot of time every time to launch application masters, launch mappers, launch reducers, and okay, load the data into mappers. Okay, for all these things it will take a lot of time. But okay, here when it comes to Spark programming, okay, so here what is happening, in case of Spark programming, it is launching 2 executors, and these executors are readily available. Okay, are readily loaded with the data. Okay, so end of this is JVM in memory. Okay, this is JVM. Okay, so when the program is started, driver will load this data into both executors and keep executors readily available. So whenever there's a request from swiping machine that will hit the driver will send it to both executors. Now executors will execute the job, okay, get the credit card details and send it back to a driver will send it back to swiping machine. Okay,
and also the load is balanced, no sir? Here they had
yes,
1,90,000.
But here 95, right?
Yeah, it is load is also shared between them. That
Yes,
is also
sir,
there.
Yes.
Sir, in HDFS in MapReduce there was a logical concept, yes,
Yes,
like
sir.
logical block. Same
Yes, sir.
concept applies here also.
Okay,
Because
you can take it.
yeah.
Okay, so that logical split, okay, is called as a RDD here. Understood? Okay. RDD, resilient distributed data set. Okay. This is what is RDD here. This is the logical data, right? Logical block only, right?
Yes, sir.
Yes or no? So this entire 250 MB credit card table data is divided into two parts now in memory.
So two RDDs we can say.
Exactly. So
Two RDDs, so two logical splits are there.
exactly. So, but in case of Spark, you will not call it like a RDD. You will call it like a, sorry, you will not call it like a split. Okay, you will call it like a RDD. Okay. So that is what I said. Okay, it is a read-only, fault tolerant, and partition collection of records. Partitioned. Okay, it means like a split of records. Okay, but why I am saying this is read? Okay, read-only is fine. How I am saying it is a fault tolerant? How I am saying this is a fault tolerant. Tomorrow, if executor 1 is down, okay. So what this driver will do, the same executor, it will start another machine, and it will load the same 94,000 records into this new executor.
Sir, once job is getting end, the executors will be stopped or still running, sir?
That's what, sir. Okay, see here, okay, there is no stop of executors. This job, okay, there's driver, okay, executor 1, executor 2. If there is no change in the table data, this will be up and running for months together.
Okay, sir. Okay.
Got it?
So those executors are in separate nodes, aren't they?
Are in the data nodes and node managers.
Oh, so this is YARN method of Spark that you explained
Exactly.
this morning?
Yes.
Okay.
Got it. So now tell me, with the help of Spark, okay, so is our processing becoming simple or not? But only thing is that, okay, so here, since okay, the executors will be up and running, okay, continuously, okay, your resources will not be released. So it means, okay, when you start a Spark job, okay, that memory, those, okay, so let's say if executor, okay, I'm saying that, okay, 2 GB plus 1 core. I'm just giving an example. Okay, let's say I have executor size is 5 GB plus 1 core. Okay, this 5 GB plus 1 is dedicated to this job, okay, which will not be released anymore until you stop it. Understand? So here, okay, so let's say, okay, so here, okay, 5 cores or 5 GB plus 1 core. I'm just giving an example. Okay. So this 5 GB plus 1 plus 2 GB 1 and all, okay, will be released, okay, at the end of the job. Correct or not? It means, okay, these resources, okay, 2 GB, 5 GB, 5 GB, 2 GB, all these resources will be released at the end of the MapReduce job. But okay, here, once job is started, okay, once job is started, maybe, okay. So here, okay, this will be like, okay, these resources will not be released until you stop the job. Okay, that is the reason, okay, if you are going with the Spark processing and all, okay, you need more and more RAM. Because, okay, when you start as first job, okay, the first job resources will not be released until you stop it. Okay, if first job is running for, okay, for 2 months, okay, so the 2 months, okay, this resources will not be released at all. Got it? Okay, now, okay, you understood what is RDD. RDD means, okay, so a piece of
But
data.
if some job is updating that credit card table itself,
Yes,
then
sir.
in that case, how this is acting, like how this will work?
What?
Like, see, users are getting added to credit card and
Yes, sir.
their
Yes, sir.
information is getting updated.
Of course, okay, whenever the table is, okay, table is added with new entries, okay, then, okay, so you will have to refresh the RDDs, executors.
Oh, okay. So programmer will take care, sir, this thing.
Exactly. Yes. Okay. The programmer has to take care of that.
And also, will there be a chance for new executors to be popped up for a different set of data? Let's say if someone is executing a different job.
Maybe on the same data, okay, you can start one more job also, right?
Yeah. And then the new executors will be initiated for that one.
Yes.
Okay.
But okay, but why you want, okay, 2 different jobs, like, on the same data?
Yeah, not on the same data, but like let's say we have 6 different applications on same cluster. So
Okay.
that means like one application is initiating a specific job, and for that the executors will be invoked. But if a different job is getting initiated from different application, then it will have its own executors, isn't it?
Yes, 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 yes.
And that executors will be finished only when he ends the job. Is that how it works, or
Yes, yes, okay. That's what's okay. Every executor will be finished only when at the end of the job.
end of the job?
Got it.
Okay.
Okay.
So this is usually integrated in HDFS in the organizations, or it is running
Yes,
as
sir.
a
Yes, sir.
separate?
Yes, okay. It is with SDFS. Okay. Okay. So now, okay, so what are the different ways to create a RDD? We will see, sir. Okay. So these RDDs can be created in different ways. So these RDDs can be created in different ways. Okay. But what are the different ways? Okay, we will see now. Okay. So before we start it, okay, so let's check whether we installed Spark or not. I guess we installed Spark already. Okay. Oh, I should have started this one. But when you install Spark, okay, only one service will be started, which is Spark S3 server. Okay. And there is something called, okay, Libby. Okay. Something called Libby. Okay. What is this Libby? Spark S3 server means, okay, you can see the jobs, okay, the completed jobs in the Spark S3 server. Spark completed or running jobs in the Spark S3 server. Okay. And okay, what is this Libby for Spark 2 server? Okay. So Libby means, okay, so it is kind of a UI to execute your Spark jobs. Understand? Okay. From UI, you want to execute some jobs. Okay. So you can use Libby. Okay. And Spark Thrift server. You know what is Thrift server? Wherever you see Thrift server, it is like, okay, external clients can submit their jobs to Thrift server. Got it? Okay. See, you are swiping, okay, your Spark cluster is in Mumbai, okay, and you are swiping your credit card in Bangalore, okay, from Bangalore to Mumbai, this driver, okay. So do you think this driver, okay, the swiping machine will directly able to read the connect to the driver? So here, okay, you will have a Spark Thrift server running, okay. So your request will come to Spark Thrift server will forward it to the respective job. Understood? Okay. So this is for external connections actually. Okay. So just started the cluster. Let's see, where are we? Not in Node. I started.
Sir, for all the services which we discussed, basically operations need to be performed by developer only.
Of course, yes,
We
okay.
we need to
Ah.
just make sure that daemons are running fine. Yes, sir.
Yes, sir. Okay, our work is to make sure the daemons are running, the services are up and running
Okay.
without any issues.
Mhm.
But okay, see, if developers are not coming to you for performance issues or okay, for anything, okay, that's fine. Okay, you can just okay start the cluster and okay, you can or okay you can just start the services whenever they are stopped and okay sit ideally. Okay, but if developers are coming to you for issues, okay, then okay, you need to know all those things.
Okay, sir.
If they talk, okay, my RDD is not loading. If you say what is RDD, then how they will think? Huh?
Got it, sir. Yes.
Okay, that's the reason okay, we are struggling so much to learn, to teach all those things. Okay, so it's almost done. Okay, so it's starting. Okay, so Spark also. This is done. Started. Okay, fine. Now what I will do, I'll go for the Spark practice document. Okay, so log into HM4SLN. Okay, so prerequisites. Okay, so let us create some sample1, sample2.txt. Okay, I'm creating two files here, sample1.txt, sample2.txt. These are the two files which okay, I just created. Okay, and I'm creating a directory and I'm pushing these files to project RF data Spark. Okay, and if the files are already available, I'm deleting them. If not, okay, so I'm pushing them to. Okay, so there are two files, sample1.txt and sample2.txt. These are the two files where what we have. Okay, if you're using Spark version 2, okay, just okay for this one. Okay, so now start the Spark shell. Okay, so how to start the Spark shell? This is the command to start the Spark shell. So normally when you start a Spark shell, okay, in Yarn, okay, if you go to resource manager UI and see, okay, resource manager UI and see applications, okay, you will have okay one Spark job started. Can you see? Can you see? Guys, okay, you can see here okay, the application ID here itself. Okay, but the application ID started. This is the application ID. Okay, it means okay, you are starting a Spark shell means okay, you are starting a Spark program. Okay, that Spark program will have okay a driver which is already created. Okay, so what is the driver URL? This is the driver. Okay, so it means okay, if you send any request to this one, it means okay, you are okay. So okay, so now I started this one, right? Okay, this is the UI available.
Sir, we can start this Spark shell anywhere in the cluster.
Anywhere, okay. So normally you will be starting this Spark shell on edge nodes. Okay.
Okay, sir, got it. Yeah.
Okay. So this is the web UI. Okay. So 4040. Okay. Anything you can take. Okay. 4040. And okay. So what is the master here? What is the master? Master equal to yarn. What does it mean? So it means okay, Spark is running on yarn here. Understood? Okay. And you have something called application ID. When it is running on application yarn, okay. So for every Spark job, okay, yarn will give the application ID. Okay. So now tell me, okay, you started a Spark shell, you started a Spark job. Okay. So now, okay, refresh. Okay, it is in running state. When this will be stopped? When this will be stopped? Okay. So now, when I stop this program, this program will be stopped. If I keep this program up and running for 2 hours, the 2 hours that will be up and running. The job will be up and running. Understood? Okay. So now, okay, you can open this UI and see what is happening in this job. if you open it a job, okay, so here you can see job, or you can see the stages. Okay, this is just okay stages for all the jobs. Okay, here storage. Okay, executors. Okay, so how many executors started? Okay, it started 2 executors here. Okay, by default it started 2 executors. Okay, but nothing is there inside this one. Okay, all the executors are empty executors. Yes or no?
Yeah, but we are not feeded any data, right? But still the job was started.
Yes, sir. Okay.
So that is the difference main here.
That's the
Because
difference actually. Without data, okay, job has started. Okay. So one
So
driver.
basically Spark Shell itself started these, yes, default.
Exactly, sir. Okay, by default, if you don't tell how many executors at all, okay, your Spark Shell has started 1 driver and okay, 2 executors. Got it. Okay. So now, okay, so what I'm saying, okay, explicitly and given at the time of Spark Shell. Okay, so fine. Okay, so creating RDD. Okay, so now okay, I'm going to create RDD space. Okay, how to create okay RDD. Okay, RDDs can be created by passing data in the command itself. Okay, let's say your data is very small data. Okay, so this is your data. Okay, maths 85, English 75, science 82, social 65. Compared, this is the subject and marks. Okay, this is your data. Very simple data. Very small data. Okay, so when you feel that your data is very small, you can give in the command line itself. Okay, now what I'm doing here is try to understand. Okay, so val marks data equal to okay, wherever you see parallelize, it means creating the RDD. Okay, so now you are giving this RDD to Spark. Understood? Wherever you see parallelize, okay, it means okay, you are creating some data. Okay, so this is RDD. Okay, this marks data RDD, you have this data. This is the data, okay, which is available in the marks data. Okay, now okay, now you refresh this one. What is the data it is showing? How much data loaded and all? Okay. No. Okay. Now let us see this one. Okay, value equal to. Now I created RDD. Now I'm creating one more RDD. This is marks data, sorted marks. Okay. Now, so this is the second RDD what I'm creating. So in this second RDD, whatever data, okay, it is sorting the marks data. So if I sort the marks data, okay, that is the value of sorted marks. Okay. Yes, this is another RDD which is created now. Okay, it means okay, inside one Spark job itself, you can get multiple RDDs. Correct or not? This is RDD. Now, okay, see, if I say, okay, I'm printing RDDs case. Okay, so if I say, okay, marks data, print, how it is printing? It is printing the data. Okay, but if I say, okay, sorted marks, okay, see the difference between okay, first one and second one. What is the data we have in first RDD and what is the data we have in second RDD? Huh? Tell me guys.
Sir.
Sorted based on
Sorted,
the
unsorted, sir.
Okay, so marks data is containing okay direct marks data, but okay, sorted marks, okay, sorted marks, okay, data has been created on top of okay, or by using okay marks data. So this is a sorted data. Okay, now okay, until this job is running, okay, you print this sorted marks. Okay, will it read from any disk or it kept this data in memory? This data is in memory now. Got it?
come from memories.
Okay, so whenever okay, you run this command 100 times, okay, it will come there. It will print the data from memory only. You got my point? Okay, it is not reading any data from any disk now. Okay, so this is one way where you can create the okay RDD by passing the data in the command itself. When you have very small data, you can create RDD by passing the data in the command itself. Okay, okay. So suppose okay, let's say okay, you have some data in a file. Okay, that file can be a big file or small file, but okay, your data is in a file. Okay, so now what I'm doing here, okay, so here, okay, so command that, okay, creating the RDD by passing input file path in the command. Okay, this is the second way. Okay, so here what I'm doing, so I'm importing. Okay, try to understand. Okay, so I'm creating a file system variables here. So now see here, where file RDD. Okay, so what is this file RDD? Equal to sample.txt. So you remember, okay, we kept one file in this location, sample1.txt. Okay, now I'm referencing that. Okay, so now when I say file RDD, where it is taking the data? Huh?
From disk, I think.
Now it is taken from SDFS. Okay, so it has taken data from SDFS. Okay, and if I print this one, okay, you can print this one actually. Okay, so if you want to print, okay, what is this? What it is printing? Tell me, guys. Is it printing this content of this file or not? Sample1.txt. If you have any doubt, okay, let us okay, print sample1.txt. Okay. STFS hyphen cat. Is it the same? Huh? Programming model. Same or not? So it means, okay, when you create RDD, what it has done, okay, it has got this data, it has got this, okay, whatever data is there in this file, it has got the data and put it inside this file RDD. Got it? Got it or not?
Yes, sir. So now is it, so after pulling it from the disk, is it keeping that in the memory, or every time it's going to
It
get
is in
from the disk?
memory. Okay, it is there. Okay.
Memory.
This file RDD is available. Okay, this data is available in memory.
Okay. Okay.
Got it? Okay. So now, okay, what I'm doing, okay, I'm creating one more RDD on top of this file RDD, guys. Okay, this is the input data. Okay, and okay, using this input data, I'm creating words RDD. Okay, how I'm creating words RDD? So by giving the split actually. Okay, when I do this one, okay, now okay, you print okay, words RDD dot collect dot println. What you will see here? Each word. Okay, so it means okay. See here what okay words RDD has done. Okay, so words RDD equal to split the file RDD. Okay, with space. Understand? With space. Okay, so that is the reason. Okay, you got okay words RDD. Okay, each word. Clear? Are any questions? Okay. So now you printed the words RDD. Okay. Now what I'm doing, I'm creating another RDD, guys. So okay, try to understand first. Okay, I created. What is the RDD I created? File RDD. This is the RDD. Okay, there's a file in SDFS. This is the file in SDFS. This is SDFS. Okay, we have a file which is called as sample1.txt. This is the file. Okay. So now, okay, you are starting a Spark job. Okay, so here you have a Spark job. So this is a Spark executor. Okay, so it's equal to sample1.txt. Okay, so it means okay, you are referencing okay a file which is residing in sample1.txt. Okay, clear? Are any questions? This is file RDD. It means okay, when you create this one, automatically, so whatever is there in sample1.txt, okay, it will come and assign it to file RDD. Okay, now this file RDD you are converting that. Okay, so file RDD you are converting into words RDD. Okay, you are converting this into words RDD. Okay. What it will contain? Words RDD. What words RDD will contain?
Split of file
Okay.
RDD.
So yeah, split of the words from file RDD. Understood? Okay. You are getting words RDD from this.
So now the words RDD is also stored in the memory.
Yes, of course. Okay, file RDD is in memory. Words RDD also in memory. Okay. From words RDD, what are you doing? Okay. From words RDD, you are creating. Okay, one more. Okay. So words key value RDD. Words key value RDD. This is what you are in now. Okay. Now if you print a words key, okay, words KB RDD. If you print this one, what you can see here? You can see each word, comma, count. Okay. So you created words KB RDD. Okay. This is okay. Can you see? This is kind of a mapper output base. So this one. So what is this one? The value of each word. Understood, sir? Okay. So now from here, you are doing the word. This is the last one. This is the last one. Okay. You are doing the word count RDD. Okay. So what is word count RDD? Okay. So here you are saying that okay, consolidate the word count. Okay. So now if you print a word count RDD, what it will give you? Now you see. Now consolidation will come. Data 2 using 2. Okay. So off came 4 times. Okay. A came 3 times. So is it a consolidation one or not? Huh? So this is the final word count. Ready. Okay. Final word count. Okay. If you still want to do something on top of this one, okay, you can still do. Okay. Sorted word. Okay. So now you are sorting the word count. You got the word count, but okay, are these in an order, proper order? No. Okay. Now you are sorting them. Okay. So now sorted word count. This is the from okay. Now if you print okay this one, okay, sorted word count. You know, okay, is it in a sorted way or not? First all capital letters, then all small letters. A, B, C, D. Yes or no? Huh?
Yes, sir.
Okay. So now this sorted word, okay, this information is available in memory. If anybody want this output, okay, instead of okay, they're doing all these things, they can directly use this one. Yes or no? So I'm preparing one data and keeping it readily available in Spark. Anybody want, they can use this data now. Correct or not?
So is it available for the people outside this session as well?
Of course, yes, yes. Okay. If anybody want to access this data, so here okay, they have the URL, right? They'll send a request to this one. This is the driver URL. Understand? Okay. If they send the request to this one, this will give you okay through this URL. Okay, they can access any of these RDDs. Okay, once this RDD is completed, generated, these RDDs are of no use. Correct or not? This is the final RDD which we want.
Yeah.
Tells me.
So for the small range to mid range data, it's okay. But if it is a larger data set and if you are keep on doing this
Okay, so
transformation,
okay, sir. Okay, now okay, this is a sample one.txt, which is of okay, let's say 100 MB. Okay. Now the execute we have taken as 1 GB plus 1 core. Okay. But what in case we have a file HDFS? You have a file with okay You will have multiple executors. Executor 1 with a portion of data. Executor 2. Okay. Executor 3, executor 4. Okay. Okay. So now you may define it like, okay, each executor size is 3 GB 1 core. Now tell me how your input data will be spreaded now. You got the point now.
Yes.
If you load into Spark, okay, is it loaded? Okay, is the entire data loaded into one executor?
No, multiple executors. So can we have multiple executors on the same
Of
node?
course, yes. So, okay, it means okay, one RDD, okay, can be stored, okay, across. Okay, one file can be divided into different RDDs and stored across different executors.
So that numbers 3 GB plus 1 core is been allocated by driver itself. It will make those assumptions.
No. Okay, we need to tell in the program while setting up this one.
Okay. Depends on the file size. Okay.
Exactly. So here, okay, 10 GB and 5 executors means each executor will take 2 GB data minimum, correct? But we need something for processing all those things. So that is the reason I have given 3 GB 1 core. Each executor. Got it? Okay. So now if you see RDDs, okay, RDDs can be created, okay, by passing data in the command line, or okay, by passing a file reference in the command line, or okay, a new RDD from existing RDD. Okay. So this is okay. So for example, okay, I've shown you like, okay. So this is the Spark executor. 1 for 1 GB. So here, okay, so here what I've done, marks data. Okay, so marks data I've given. Okay, marks data I have not referenced anything. Okay, so this is the marks data I've given. I pass this information in the command line itself. That's or no? Okay, the first way is that so I pass the information in the command line itself. Okay, so from here, from marks data created sorted marks. Okay.
So now with the same data on the right hand side, the sample.txt we have like 10 GB, right? And
Okay.
we have the data in all the executors. And now if someone wants to convert that file to a different format, so
Okay.
then they will need the 3 GB of executor in the same node. So is it going to auto allocate, or even for that file they will be providing the executor information for that new transformation maybe?
Yes.
Okay.
Okay. Okay. Here are any questions? Okay. This
So
is
the
one way
Spark-
by passing the data in the command itself. Okay. This is second way. Okay. You're referencing a file from the STFS. And okay. This is third way, creating an RDD from previous RDD, from existing RDD. These are the three different ways where I can use this one. Okay. Understood, or any questions?
Yes, one thing,
No.
sir, if Spark has to stop, means the daemon has to be stopped. Then only it will job. If you have to stop any job or thing, you need to stop the daemon itself, right? Then only it will get stopped.
This okay, Spark job itself. Okay. Spark job itself. Understood. Okay.
Come again, sir?
No. So if you want to clean up this one, okay, you stop entire job. Then the executors will be released. Now nothing will be there in the memory.
Okay.
Okay.
So we can start a new job after this.
Yes. Again, okay. When you start, okay, these steps will be repeated on it. Okay. Again.
Sir, it will keep only last RDD as in memory and flush all other previous RDDs, yes?
Sorry? It is keeping given previous RDD also.
Okay, sir.
Okay.
So it will be very hard, yes, like kind of keeping all the RDDs in memory.
Of course, yes, but okay, so every time, okay, see, every time you want, okay, so, okay, but if you want to delete, okay, so I never start cleaning up these old RDDs. Maybe, okay, there may be an option, okay, to clean up this old RDDs, guys. Then, but okay, I never saw, okay, clean up that RDD cleanup actually.
Okay, sir, got it.
Okay. So, and okay, if you want to store the output, okay, if you of any of the RDD, you can store. Okay. So here, okay, you can say sorted words RDD. Okay. Save as text file. You can save it actually. Okay. You can save it in the project data Spark and word count directory. Okay. So if you do this one, so what it will do? So now you go and check in this location. Check the path, this location. Okay. Project RF. This is the location, right? We used. Okay, so SDFS, DFS, LS. Okay, take this part. Do you have the data or not? Okay. So we have two RDDs. Okay, so both one created, one file. Okay. So now SDFS, DFS hyphen at is the first one. Okay, and this is second one.
So the output can also be stored in this
Yes,
tab.
yes. Got it.
Your start a Spark, it will by default it will be up and running with what do you say with like application master node by default it will be up and running.
Yes,
So
sir. Yes.
the once you stop, nothing will work. The Spark won't work at all, right?
Once you stop the job, okay, you cannot access any of these things. Okay, and check the output by changing the source file path. Okay, now you give the different one to file RDD. Let's try to understand. Okay, so now I'm passing sample2.txt for file RDD. I change the file. So now if you see, this is what okay we did. Okay, now I'm referencing a different file. Okay, so I'm saying the file .rdd equal to different file. Okay, sample2.txt. Okay, now you check this one. Sorted words RDD. So can you guess, guys, will it print sample2.txt word count or sample1.txt word count?
It should be sample2.
Sample2, na? But it is printing sample1 only, na? So that's what I told, okay? See, here, this is already generated. This is already generated by, so now if we change this one, will it change this one? See, each RDD works individually. Understand? Okay. So I change this one. Okay, that will not impact this one or this one or this one or this one.
Yeah, but in the select you're doing on file RDD, right? Did you do on words RDD?
Even words RDD also same thing.
Oh, sorry. You sorted on words RDD. Sorry, I thought you sorted on file RDD.
No.
Okay. Got it.
Okay. So if you change the previous RDD, that will not change the next RDD. That's what I'm trying to say here.
Yeah, got it, sir. You're replacing the variable. Okay.
Yeah. Okay. So that's all about RDDs. Okay. So it means so whatever data you have, Spark will get the data and put it into memory and keep it readily available. So if anybody wants the data, they will just access the data in memory data. That is the reason Spark is very fast. You got an idea now?
Yes, sir. This looks like a totally different language. We as an admins, is there any
Sir, okay, for Spark, you will not have, as admin, you will not have any scope.
Okay.
Because if Spark job is stopped, they will restart it. Okay, developers only will restart their jobs. Okay. Or maximum, so what they will do, they will ask us to restart. Okay. You'll have some commands to restart. That's it. They will only give, developers only will give the command how to restart. We just follow those commands. That's it. Nothing other than that.
Okay, but there is no other way to, like, let's say, to use a SQL engine from the Spark, right? It's not possible.
Sorry?
We cannot be able to use a SQL language from the Spark, isn't it?
You can, sir. I will show you that also. Okay.
Okay. Okay.
Okay. So now, okay, let us understand okay, the Spark
Yeah,
program. Now
before
you
that, can you explain which daemon will run on which node and kind of while
that
configuring?
okay, I'm explaining, sir. That I'm explaining.
Okay.
Okay. Nothing is running. Okay. So only the Spark STS server is running. Okay. But now let us see. Okay, what is the Spark program? How it works? Okay. When it's a Spark program. Okay. So what are the different things you will have? Okay. You have a driver program. You have okay executors. Okay. So driver program and executors. In between you have cluster manager. Okay. Now let us understand here. When I say Spark program, every Spark program will have a driver. It's a driver. Okay. So this is the driver. Okay. Driver. Okay. Driver program. Inside this driver program, we have Spark contest. Next. Okay. So what is Spark contest? Okay. If you take the driver program as a house, Spark contest is the main door. Okay. If Spark contest is not started, there is no use of driver program. Understood? So this is the entry point for your Spark program. Okay. Anything want to access some data inside the Spark job. Okay. So they should pass through the Spark context. Got it? So when you will say that the Spark context is started, okay, if you get the URL like this, okay, here, okay, so if the Spark context is started, okay, so Spark context is started means it will give you a URL like this actually, okay, and okay, for each Spark context, okay, you can set up your own URL also, okay. Here, okay, it has given a default URL, but if you want to set up your own URL, you can set up your own URL also, okay.
So you set it up as a variable.
You can, sir. Yes.
Okay.
Okay. This is the Spark context. Okay. So now, okay, under Spark context, okay, what you will have? Okay, under Spark context, okay, you will have worker nodes. Okay, these are the thing that this is a worker node. Okay. So worker node, okay, inside worker node, okay, you will have executors. Okay, this is the thing that this is worker node. Okay, worker node 1 and worker node 2. 1 of worker node 2 and worker node n.
Like data nodes, right? Wherever Spark is.
I'll tell you, sir. I'll tell you what are these nodes.
Okay.
Okay. So now, okay. Now when you start a program, okay. So okay, while submitting the program, okay, you will have to tell. Okay, developer will tell. Okay. So I need okay Spark program, okay, with okay one driver of size, okay. Let's say 5 GB plus 1 core, okay, and okay, will tell. Okay, so I need okay. So executors. Okay, 3 GB plus okay, 1 core. Okay. So now, okay. So where this driver program is launching, okay, is a different scenario. Okay, I will talk about this one. Okay. So now here okay, we are saying that okay, 3 executors. Yes or no? Huh? 3 executors. Okay. So normally executors will be started on worker nodes. Okay. So here, okay. So maybe this is executor 1. Okay. Executor 1. Okay. Maybe here okay, you have executor 2. You have executor 3. Since you asked, okay, I want 3 executors. Okay. So executors are launched on worker nodes. Okay. Okay. Now the question is that, okay, in between you have, okay. So here you have a cluster manager. Yes. Okay. So if you are using cluster manager as yarn, okay. So if the cluster manager is yarn, okay, your cluster manager is yarn means okay, your worker nodes are nothing but okay, node manager 1. Understood, sir?
Yes, sir.
Huh? If your cluster manager is yarn, okay, it means if your cluster manager is yarn, okay, so your executors will start on node managers. Understand, sir? Huh? I will show you the same job in a different way. Okay, your cluster manager is on. Okay, is on. Okay, Spark scheduler. Okay, then your executors will start on. Okay, Spark node 1. Okay, so okay, if you see the real-time cluster here, okay, suppose okay, if you are using okay, if you are in Spark, okay, if you use the cluster manager as yarn, okay, cluster manager as yarn, okay, your Spark job executors will start on these nodes, okay, on these nodes. That is the reason I say if it is yarn, okay, your executors will start on node managers, okay. But okay, if okay, you use Spark scheduler as the cluster manager, okay, so Spark instead of Spark scheduler, okay, we call it a local actually. Okay, so in this scenario, okay, your worker nodes will be, so your executors will start on these nodes. Understood? Okay, your cluster manager is the one who will decide, okay, who will decide, okay, where the executors to be launched, okay, whether you want to launch executors here, whether you want to launch executors here, that will be purely decided by your cluster manager, okay. So when people will use yarn, tell me, when they integrate your Spark with yarn, okay, so when they are reading the data from Hadoop, when you are using Spark with Hadoop, okay, then they use yarn, so that okay, all the executors will start here, okay. But okay, so there are people who are using Spark without Hadoop, then they will use this one, they will use cluster manager as local. Understand? Okay, but which one is better? So here, okay, let's say you have 10 Spark workers, but okay, here you have 100 node managers. Which one is better? Which one will have more resources?
Hadoop, HDFS.
Of course, yes, okay, Hadoop, okay, yarn will have more resources. Understand? Hadoop yarn will have more resources than, okay, individual Spark cluster. Okay. So, and one more thing, okay, what is the advantage, okay, if you run on yarn, okay, in yarn, okay, we have a concept, if any container, okay, every container will have maximum 4 attempts, yes or no? Yes or no, guys? So,
Yes.
if mapper is down, okay, it will be retried, relaunched automatically, okay, reduce is down, relaunched automatically. In the same way, so if executor is down, okay, it will be relaunched automatically, okay, but those relaunching of workers, okay, the executors, okay, in case of any failure may not be available here. But here, because of the yarn, see here, okay, relaunching of executor is happening because of yarn, not because of Spark. Understood? Okay.
Sir, where driver will be launched? It will be launched in master node.
Okay, so that's the next question. Okay, so where the driver will be launched, okay, that I will explain now. Okay, but okay. First, okay, I'm talking about the executors. Where executors will launch, I'm talking.
So basically, sir, paralleling will be better in yarn. Like parallel.
Hmm?
Like if we want to achieve more performance, better
It's
it
better to
will
go with
long.
yarn. That's what
Yarn.
okay.
Okay,
Spark
sir.
on yarn will give you okay super duper performance than this one. Than this one. Okay,
Got it,
then
sir.
Spark alone, okay, Spark and yarn will give you more performance. Okay. So now you understood, okay, so you have a driver program. Okay, so based on the cluster manager, the executors will start. Okay, what is executor here? In each executor will have okay cache. Okay, so this cache is used to store the data. Okay, so here okay, we understood that okay, inside the executor, okay, the data is being stored. Okay, where the data will stored inside the cache. Okay, and executor will execute the task. Okay, so whenever okay you ask okay, so I want to print sorted word.dd. Okay, is it printing or not? Okay, so like this okay, you can print okay, any number of tasks. Okay, you can give any number of tasks to the executor. Executor will execute this task on this cache data and give you the result back to Spark context. Understood? Okay, understanding Spark program is very simple, guys. Okay, so here we have a Spark driver. So driver is a Java process. This is the process where the main method of Scala, Java, Python programmers to execute the user code and create the Spark session. Okay, or Spark context, and the Spark session is responsible to create the data frame, data set, RDD, execute SQL, perform transformations, actions. Okay, everything. Okay, Spark driver is the entry point for your okay. Spark driver is the main method. Okay, so this is the place where the main method will start. Okay, so this is the one. Okay, so if you start the Spark driver, okay, it will start the Spark contest or Spark session. So which will help you to create the data frames, RDDs, okay, and execute some SQL queries or perform any transformations, all these things. Okay, so this is the Spark driver. Okay, now what is Spark contest? Spark contest is the entry point of the Spark functionality. Okay, the most important step of any Spark driver application is to generate the Spark context. Okay, so your application will be up and running until Spark contest is stopped. Okay, so here okay, driver program is kind of application master, but for that application master, the entry point is Spark context. If the Spark context is not open, okay, not started, even driver program is started also, there is no use. Understand? Okay, so Spark contest is important. Okay, until the Spark contest is up and running, your Spark job will be up and running. Okay, and Spark cluster manager. Okay, Spark supports multiple cluster managers like standalone. Okay, RKO, over yarn, Mesos. Okay, so this is okay. So here, okay, you can say standalone. Okay, Spark scheduler. Okay, so it is a standalone. Okay, they call it a standalone cluster manager. Okay, so which will help to control the resource allocation to multiple Spark applications. Okay, so here, okay, this cluster manager is the one who will help, okay, where to launch the executors. Okay, if you are using standalone Spark, okay, then okay, the executors will be launched on Spark worker nodes, and if you are using over yarn, okay, executors will be launched on node managers. Okay, and what is executor? Executor is okay, is the worker node process in charge of running individual tasks. Okay, so for a given Spark job. Okay, so executors are worker node process which are responsible to store the RDD's data and to execute the task based on the requirement. Okay, so they are launched at the beginning of the Spark application. Okay, so here these executors will launch at the start of the job, and they typically run till entire lifetime of an application. Till end of the job, executors will be up and running. Okay, so once they have run the task, they send the result to the Spark driver. Okay, so what they do? So normally what will happen? Okay, so whenever, okay, let's say I want to print. Okay, here guys, okay, I'm saying that print sorted word. Okay, now it is printing, right? When you give this command, okay, so this command is hitting whom? In this example, it is hitting whom? Huh?
Driver.
The driver or context?
Driver only, sir, I believe.
See, it is hitting the Spark context inside driver, not driver. If I hit only driver, okay, what is the use? Huh?
Got it, sir.
Okay, so if you want to enter into this driver program also, okay, the entry point is Spark context, right? So okay, whenever okay, you run any command, okay, that command is coming to Spark context. Okay, now you're asking okay, print it. Okay, print it. Okay, so do you think okay, all this data is available in one executor or two executors?
Executor.
Huh? Okay, now you see when I store my data, how many files it created, guys? Huh?
Executors.
2
Two
files.
files. It means how many executors?
2
Two executors. Okay, so the data is not in one executor. Okay, so whatever data is printing, it is in two executors. Okay, so when you give the command print command, okay, immediately okay, it is hitting this. Okay, it is hitting the Spark context. Spark context is converting that command, your command, into task and giving it to all the executors here. Okay, each executor is executing the task, okay, and sending the partial result back to Spark context. Now Spark context is merging all the result and printing it on the screen. So this is what is happening, guys. Understood?
Sir, at some point of like if we are seeing my cluster now, there may be a chance that there may be multiple drivers and multiple
Of
executors.
course, yes. Okay, so this is like a one driver, sir. Okay, like this, I can execute multiple programs at a time, right?
Got it. One program means one driver, correct,
Yes,
sir?
one program is one driver.
Okay, sir. Got it.
Okay, so to this driver, you can submit any commands, any number of commands.
Sir, in real time, which one will be used more here? Standalone Spark or this?
It depends on the
Spark
company, sir.
with
If they're using Spark with okay, they already have Hadoop cluster. Okay, then okay, they use Spark with Yarn. Okay, they don't have Hadoop cluster, but still they are using Yarn. Okay, they will use standalone. Okay.
Is choosing the cluster manager is also variable?
Yes, sir.
it
You can
depends on
decide
the
which one
environment?
you want. Yes, yes. In the command itself, you can tell. I will show you that also. Okay.
Okay.
Now you got an idea, right? How the Spark job is working here. So now okay, let us talk about the cluster managers. Okay, what are the different cluster managers we have? Okay, we have standalone, over Yarn, and Spark in MR. Okay. So here, okay, when it comes to standalone, it is a simple cluster manager that is included with Spark. Okay, we can start Spark manually in this mode. Okay, so this is the simple cluster manager where okay, your executors will start it in this area. In this area. Okay. So you know it. Okay, so here okay, normally okay, this standalone mode will be activated when you install Spark itself. Okay. But when you install Spark with Yarn, over Yarn, okay, in this setup, Spark uses Yarn to manage resource allocation. Okay, so here who will okay, so which executor will be launched on should be launched on which machine, which node manager is purely decided by Yarn. Okay, inside Yarn resource manager. Okay, so there are two modes in this setup. Okay, in this cluster mode. Okay, so okay, all these days okay, I was talking like okay, I was talking about okay. I mean, all this time, okay, I was talking about, okay, where executors will be launched. Okay, there is a question, okay, which is left out, okay, where driver program will start. Huh? Understand, guys, where driver program will start. Okay, that's important, right? Okay.
Yes, sir.
Yeah, driver program also. Okay, so let me create, okay, so here, okay. Okay. The question, okay, so where to launch the driver program. Okay, so you understood, okay, where to launch the executors. Okay, launch of executors is purely based on the cluster manager. Okay, but when it comes to driver program, okay, where to launch. Okay, okay, different ways, guys. Okay, so now I will come to this one. Okay. Okay. Parkin. So this is the program which we have seen, guys, till now. Okay, this is the program which we have seen till now. Okay. Now let's talk about standalone mode. When it comes to standalone mode, Parkin standalone mode. Okay. So okay. In case of standalone mode, okay. Okay. Okay, you understood what I'm trying to say here. Okay, in case of standalone cluster manager, okay, let's say two users submitted a job. Okay, so user one submitted a Spark job one, user two submitted Spark job two. Okay, so here user one Spark job has one driver and two executors. So the jobs will be submitted where? Here. Okay, on Spark worker one. Huh?
As a node, sir, job will be
Not
submitted.
this is the Spark standalone means, okay, so this area.
Okay.
This area. Okay, so it means the drivers also started here, executors also started in any one node. Okay, so driver is started in this machine. P1 means, okay, RK, so you can say instead of P1, okay, job one, okay, here also job one, here also you have job one. Okay, so here, okay, this is job two, okay, this is job two. Okay, what does it mean? Tell me. What does it mean? Okay, so here, okay, I have Spark job one. User one submitted Spark job one. Okay, first job one, okay, the driver is started here and two executors are started here. Understand? For user two submitted Spark job two, for this Spark job, okay, driver is started here, executor is started here. It means, okay, Spark workers can launch, okay, driver programs or executor programs both. Clear? This is the Spark standalone mode. Okay, so your drivers and executors, okay, everything will be started in the worker nodes only. Are you clear? Are any questions?
And cluster manager decides where to launch the driver.
This is the standalone cluster manager will decide, okay, out of these four machines, okay, in which node, okay, driver one should be launched, in which node, okay, job two driver should be launched, in which node job one executor one should be launched, like that. Got it?
Does it use any algorithm or it just?
Yes, it uses some algorithm, sir. Okay. Okay. So this is about standalone mode. Okay. But when it comes to Spark and Yarn, okay. So now you talk about Spark and Yarn. Okay. So here, Spark and Yarn. Okay, you can decide now when you are using Spark and Yarn. Obviously, executor will be started on the node managers. Correct. Executors will be started on the node manager. Correct or not?
Yes.
Okay. Executors will be started on the node manager, but okay, you have an option to decide. Okay, where to launch the driver. Okay, you can tell. Okay, if you say deploy mode equal to client, your driver will be started on the edge node. Understood? Your driver will be started on the Spark edge node. Okay, and executors will be launched on the node managers. Okay, so that advantages here is that okay, fixed URL is fixed. Okay, so here if edge node is HN4, this is the fixed URL you will have for this one. Okay, so and disadvantage is if edge node is down, your Spark program will be stopped, will be dead. Yes or no? If driver is not there, so there is no use of these executors. Okay, so if the Spark is if edge node is down, the Spark driver will go down. If Spark driver is down, then entire program is down. This is the disadvantage. Okay, so now we have second thing, deploy mode equal to, this is the another deploy mode.
Sir Venkat sir, deploy mode is equal to client means what it means?
Right?
Deploy mode equal to client means what does it mean?
I'll tell you, sir. I'll tell you. Okay, now you see. Okay. Deploy mode equal to client means, so you are telling that so you launch my driver on edge node and executors on node managers. That's what you are telling. Okay, but when you say deploy mode equal to cluster, you are telling that you launch my driver also on node managers and executors also on node managers. Understand? Okay, so here what is the advantage here? Okay, if the driver is down, if the driver is down, automatically your resource manager or Yarn will launch one more driver, one more attempt of driver. Correct or not? Yes or no?
Yes.
What is the advantage here, guys? So what is the advantage of this? What to say? Advantage of Yarn. In Yarn, if any container is down, automatically it will launch one more attempt of the same container, right? If mapper 1 is down, same mapper 1 attempt 1 is down, mapper 1 attempt 2 will start in different node manager. Correct or not? Okay. So here, so the advantage is that if the driver program is down, then your resource manager will start this driver program in some other node. Okay. So in that scenario, earlier, let's say in here it is a fixed URL. There is no change. Always your driver will be running here only. Okay. But here, is there a guarantee that my driver will run here only?
No.
Okay. Today it is running here. Due to some issues, somebody stopped the node manager. Okay. So now driver will be relaunched on this machine. So in that case, URL will be different. So here, so here, hn4.hadoop.com. Okay. But here, hn2.hadoop.com. The URL is changing. Driver URL is getting changed. Okay. So disadvantage is that variable URL will be changing based on the node it is running. So developer has to manage the URL part carefully. He has to give a fixed URL. Let it run here or let it run here. Okay, the URL should be this only. Okay, mysparkjob.hadoop.com instead of NM4 or HN4 or HN2 like that. Understood?
Sir, one doubt here. If you say Spark on Yarn, so Spark is installed in Hadoop cluster, or is it installed on outside Hadoop cluster, sir? For Spark on Yarn.
Okay, so Okay. Now you see, sir, where Spark is installed. Is it installed on these nodes? If it is yes, okay, I would have put okay, Spark here, right? But in the Edge nodes, okay, you install Spark client. Understood? Okay. And on these nodes, you will install Spark.
Okay, still Spark is installed outside only. Okay.
Yes, yes, yes. Clear?
Yes, sir.
So for in Edge nodes will be Spark client is there,
Yeah.
but nothing is there inside cluster. Yes, sir. For in
Sorry,
YARN
sorry?
mode also.
In YARN, okay. In YARN, okay. Suppose if you are using YARN, you can decide, okay, where to run driver. Obviously, executors will run here only. There is no change, okay. In
Yes, sir.
executor execution, okay. But driver execution, whether it should be here or here, that's purely decided by
Developer.
developer. Yes.
Okay, sir. Got it.
Okay.
So, sir,
this-
basically for a cluster which is already there, this only means as an admin, we need to just install Spark client in the Edge nodes.
Yes,
So
yes.
that
Yes, sir. That's it.
But if he's installing, he has to consult admin, no, sir, because it matters. It's a matter of resource availability. Since you have a lot of memory being consumed, so you have to take that into consideration also, right? So you cannot just blindly install. No?
Okay. See, install Spark client, how much it will take? Sir, okay. So, Varghese sir, try to understand here. Okay. So where I'm installing Spark, to install Spark client, it will not take. Okay. Spark is not a big program.
Yeah, I know, but if you tomorrow, if you are doing some processing, right? So obviously it is a memory.
The processing will happen, okay, on the executors, sir. Okay, executors are here. Understand?
Yes, correct. Yeah, yes, sir. So he'll obviously has to consider the because he has to obviously has to discuss with the admin, right? Because it is since it's a more it consumes more memory, so it can impact other activities, right? As a for the active other jobs.
Yeah, that is the problem, right? In Spark, okay, see, in case of MR, your job will start to execute and close. Okay, release the resources. But okay, it is not the case in Spark. That is the reason if you want to run Spark jobs, you need to keep more RAM in your cluster.
Yes, yes. That has to be factored, yes.
Sorry, you are getting performance means you need to sacrifice in some place. You need to invest money on RAM. Got it? Okay. So this is okay. Third mode, okay. Spark on Mesos, okay. But okay, nowadays nobody is using Spark on Mesos, guys. Okay. So normally, okay, if you want to use what to say, SDFS and LPMR, okay. So, but nobody is using this one, okay. So people are using either this one or this one, but okay, this will give you the more okay performance. So
in terms of production environment, I think we should prefer always YARN because we want always fault tolerant system.
Yes, yes, sir. Yes, sir. That's what. Okay. So Spark driver runs in in case of cluster mode, Spark driver runs inside a master process managed by YARN on the cluster, but in client mode, it will run on the Edge node. That's very simple.
Sir, let's say the node where the driver is down, node where the driver is initiated. Let's say it's down. It is going to initiate into a different name node. Sorry, different node manager.
Yes.
But because that the URL is going to be changed, so that job is gone.
Sir, okay. See, okay. Now you are starting a Spark job, sir. So starting a Spark job. Okay. So let's say this is the credit card job. Okay. Credit card job. Okay. So now, okay. So let us take this now. This is okay. This is your driver. Okay. This is executor 1, executor 2. So there are 4 executors like this, sir. Okay. This is your Spark job. Okay. This is your Spark job. You clear?
Yes.
Okay. Now, okay. This is the Spark job you are starting. Okay. Every driver should have a URL, right?
Yeah.
Okay. Suppose, okay, let's say this is, okay, edge node 1, okay. Edge node 2. Okay. Here I have driver. Okay. So now, suppose, okay, if it is running on edge node 2, maybe the URL will be like, okay, https:// okay, en to edgenode2.hadoop.com, okay, colon, okay, 4041. This is the URL, sir. Okay. This is the URL of this driver. Will you agree with me?
Yes, sir. This
Okay.
part totally understand.
Okay.
If it
No,
is
no,
found
no.
that
Suppose, okay, if I run the same Spark job, okay, on edge node 1, okay, then what will be the URL? Edge node 1.hadoop.com 4041. Okay. It means, okay, if you run your driver here, URL is changing. If you run your driver here, URL is changing. Yes or no? Okay.
yes.
But okay, here, okay, so here, okay, you have a swiping machine. Swiping machine, whenever you want to find the credit card details, okay, you will tell inside the swiping machine, okay, it is programmed in such a way that, okay, always connect to https:// okay, mycreditcard.hadoop.com. Okay, my credit card, okay, HDFC bank.com. Understand? Okay. So now suppose, okay, in this scenario, what you need to do? Swiping machines will always connect to this mycc.hadoop.com only. Okay. Now you need to use this like a load balancer, and you need to tell, because you don't know where it will be running. Okay. So what you need to do? Okay, whenever you are launching a driver, your driver URL should be pointed to this one. Then problem solved. We don't care where it is running, okay, but okay, the driver, once the driver is started, okay, it will bind this URL to this URL. Okay, then all swiping machine will send the data. See, swiping machine doesn't care whether, okay, your driver program is running on edge node 1 or edge node 2 or anywhere. Okay, so swiping machine, okay, whenever you swipe a card, okay, it will send a request to mycreditcard.hadoop.com, hdfcbank.com. Okay, so now this URL where it will point is the question now. Understand?
Sir, who will do this pointing?
This mapping will be done by developer.
Okay, sir.
Understand? Okay, so if the mapping is not happening, okay, then what will happen? If the developer is not taking care of the mapping, okay, so if the driver is working here, then okay, this URL will reach. Okay, but if driver is dead here and okay, driver is running here, will this URL point to here? No, right? Okay, whenever driver program is changing, okay, now driver has to remap, okay, this URL with this URL. Then only your job will run. Okay, see, for customers, okay, I cannot give 100 URLs. See, in my Hadoop cluster, okay, we have 2000 node managers. Okay, when I start a driver program, it can start in any node. But okay, will I give a 2000 nodes information to customers saying that, hey, if it is not working this URL here, okay, you try in this machine, you try in this machine. Can I give like that? No, right? Customer should have only one URL. That URL, okay, wherever out of these 2000 nodes or wherever your URL is running, okay, wherever your driver is running, I don't care. But that driver, okay, URL should point to this one. But then only it will work. So the managing of URLs, okay, is developer's headache now. But if it is in a fixed edge node, okay, so then okay, so it is not okay. So here okay, it is not here. Okay, always in edge node 2 only. Okay, if you do once, okay, that's fine. But if your driver is starting here today, tomorrow it is starting here, day after tomorrow it is starting here. Again, the point of URL okay, should be managed by developer in the code itself. And okay, it should not be done, okay, whenever it is done, it should be done on the fly. Whenever new instance of driver is running, launching, it should bind, okay, the URL to this one automatically. Okay.
Yeah, so when that happens, during that switch, will all the executors information will be gone or will be still there?
Why, sir? Why executors information will be gone? But anyway, okay, Spark history server will be having this information, right? Where executors and all.
Yeah.
Here also you have a job history, JSON, everything will be there, sir.
Okay. Okay.
Got it?
Yeah.
Yeah.
Sir, one just query. We told we need more RAM in case of Spark. So, sir, basically, my question is like, whose RAM? Like whether if it is client mode, this driver will be launched in Edge node.
Yes, sir.
So basically, it is utilizing more RAM.
Suppose, okay, I'll tell you one thing, okay. If 10 people are launching 10 different programs on the same Edge node, what will happen?
Then it will collapse.
10 drivers will be launched there, okay? And these programs are not stopped today, okay? Until it's stopped, okay? So we have, okay, let us take, okay, the Edge node, okay, I have a Spark Edge node with, okay, 120 GB RAM, sir. I'm just giving an example, okay? So now, okay, you started as, okay, there are 10 developers logged into this Edge node. They started 10 jobs, okay? So it means 10 drivers are running here, yes or no?
Yes, sir. Yes.
10 jobs, 10 drivers, okay? 10 jobs, okay?
10 drivers.
Okay? They're taking, okay, let's say, okay, 120 GB, okay? Or 120 GB, okay? Now in this machine, until if I stop any driver, can I do any other, can I start any other program?
No. It will be still there.
Suppose, okay, if these 10 jobs will run for next 2 months. Okay, next 2 months, this Edge node is fixed with these jobs only. You cannot do anything on this Edge node for next 2 months.
Got it, sir.
Okay, so that's the reason, okay. So it means you are blocking Edge node here for these 10 jobs.
Got it, sir.
Hmm.
So basically, see, if on the fly some job is running, so executor will execute that job, and storage, like the output will be stored in driver. Is it correct, sir?
Given to driver will pass to swiping machine here.
Okay, sir. Okay,
Yeah.
so during that time, the driver will only store the because if we are accessing same data again.
Sir, okay, your driver is there, and your executor is also there.
Yes, sir.
Your executor is also up and running only.
Okay. So, sir, my question is like, it will go again and ask executors.
Sir,
for the output,
okay, you take
previous
swiping
output.
machine, okay? This swiping machine, okay, whenever you are swiping card, okay, you insert the card here. Immediately
Yes,
swiping
sir.
machine will read your card and send the detail, okay, request, okay, this URL for the details.
Okay, sir.
Okay, this URL, okay, so is pointed to driver. It means, okay, swiping machine is sending a request to driver.
Yes, sir.
Now driver will ask this for example, hey guys, okay, so this guy is asking, okay, credit card number 1234. Give me the details of credit 1234 credit card.
Okay,
This
sir.
will check and okay, give the result back to driver. Driver will send back to swiping machine. So it means one task is completed here.
But second time, sir?
Second time, okay, let's say. So now this is okay, Bangalore. Now this is in Chennai. Somebody is swiping the card. Again,
Yes,
okay, this swiping machine will send the request to the same URL.
Mhm.
It will come to same driver. Okay. Now the same task will be given to all the executors. Okay. Now driver will ask this executor, hey guys, I want now 2345 credit card. Give me the details. It will get the 2345 credit card details from here and give it back to swiping machine too.
Got it, sir. Now I got it. Yeah. Okay.
Yeah, right now. So every time, okay, these are fixed. This okay. Who will be sending the request? Okay, is maybe changing. Got it.
Got it, sir. Yes.
The next one is a Spark application execution flow. Whatever I explained now, okay, the same thing I put in the theory, but nothing to start here. Okay, nothing to.
Sir, one more question. You explained that Spark client will install in Edge node, but what about Thrift server? Where will it be?
Now, okay, you tell me where you want to install Thrift server.
Sir, in Edge node only, yes, because
Edge node only. Yes. Okay, Edge node only, yes.
So, sir, basically, we while installing, it will ask for where to install Thrift server. We'll give Edge node location.
Normally, okay, Thrift server will be installed. Okay, suppose okay, if you are using okay, Spark with Yarn, okay, Thrift server will be installed here, sir.
Okay, sir. Got it. Got
Okay.
it.
So if there is no Hadoop, your thrift server will be in any one of these machines.
And two more daemons were there, sir. You told us live
Okay.
something.
Spark
Yeah.
S3 server. Okay. To see all the jobs of Spark job. To see all Spark jobs. Okay.
Yes, sir.
And Livy server. If I now everything I'm doing in the command line. Correct or not?
Yes, sir. Yes, sir.
What is Hue? Hue.
You,
Kind
sir.
of a UI for developer, right?
Yes, UI for developer. Correct.
Livy is a UI for developer. UI for Spark. Got it.
Yes, sir.
Okay. Okay, guys. Okay, so we'll go to the next one. Okay, so here, okay, there is one more important thing we can Spark, okay, dynamic resource allocation. Okay, what is this dynamic resource allocation, guys? What is dynamic resource allocation? Okay, maybe at times, okay, so you may have to use, okay, more executors to handle the request, okay, and okay, less executors to handle less requests. Okay, so normally, okay, so you take this one, Spark job. Okay, so this is the Spark job. Okay, so you're saying that, okay, my Spark job will have one driver plus 10 executors. Executors. Okay. One driver plus 10 executors. It means, okay, so it means, okay, one driver, okay, so one driver plus executors, one driver of, okay, size, okay, so 5 GB plus 1 core, okay, 10 executors of size, okay, 3 GB plus 1 core. Okay, now tell me, to run this Spark job, how many resources are required? Total resources required? 35 GB RAM plus 11 cores. Yes or no? Then 35 GB RAM and 11 cores will be purely, okay, what to say? Will be purely dedicated for this Spark job, and okay, they will be used for this Spark job until the Spark job is stopped. Can I say these are like, okay, dedicated resources? Huh? Can I say these are like dedicated resources?
Yes, yes, sir.
Okay, these are dedicated resources. Okay, so now, okay, now think like this, guys. Okay, so now what this Spark job will do? Spark job will get some information. Okay, so based on the user request, okay, Spark job will get some information and give the result back. Okay, so that. Okay, so I'm giving you one more example here. We're given the same, okay, example, guys. Okay, now, okay, so this is what I'm telling, sir. Okay, this is the Spark submit. Okay, I'm saying that, okay, you have driver core 1, driver memory 16 GB, and executor core and executor memory 2 GB. Okay, so deploy mode equal to client. Okay, this is what I told. Okay, so for this, okay, now, okay. Okay, sir, you think, okay. Same example like I'm giving here also. Okay, so now this is the Spark driver. Okay, so all the swiping machines are, okay, sending their request to here. Okay, so here this is Spark submit program 16 GB. Okay, this is the one. Okay, now you take the swiping machines, guys. You take the swiping machines. Okay, so do you think that, okay, so whole day you will have, okay, same frequency of swiping?
No, sir.
No, right? Okay, so let us take this one. Okay, 12 AM to 6 AM. Okay, 12 AM to 6 AM. Okay, this first 6 hours. Okay, normally, okay, very less swipings, right? Who will swipe night at 12 o'clock? Very less people. Okay, so whoever is doing the online transactions, maybe those people will be doing the swiping. Okay, but normally, okay, night 12 to 6, morning 6, okay, will be less. Okay, so you have only 100 swipes. Okay, so one executor is sufficient. Okay, 6 to 9, these 3 hours, okay, 200 requests are going. Okay, or let's say 200 requests are going. Okay, so here one executor is sufficient. But okay, 9 to 6. Okay, these 9 hours. These are business hours. Here 9,000 swipes are happening. Swiping requests are coming. Our swiping requests are handled by our job. Okay, so here, okay, in this scenario, okay, during business hours, I require 9 executors. Okay, and after business hours, again, I require only 1 executor. Okay, only 1 executor. Okay, now tell me, so here, okay, so 1 executor can handle 1,000 swipes. Okay, based on this one. So here, okay, to process this one, okay, I require. So during this time, I require only 1. If I have only 1 executor, that can handle my job. Okay. During this time also, I require only 1 executor. During this time also, I require 1 executor, but only during this time. Okay. So it means out of 24 hours, only 9 hours, okay, I require 9 executors. Remaining time, I don't require 9 executors. Correct or not?
Yes,
Correct
sir.
or not? Yes. Okay. So now the question is that, okay, suppose like if I go like this, okay, what are the total resources here? Okay. Total resources used. How many here? Okay, so total resources. Okay, here nine executors. Okay, 2 GB each. It means like a 9 into 18 plus 16, 34 GB. 34 GB RAM plus, okay, and 1 driver and 9 executors, 9 cores. 9 core. Okay, 10 cores total. Okay, so for this Spark job, okay, 34 GB plus, okay, 10 cores are fixed. Yes or no? Okay. But actually, based on my requirement, okay, morning 12 to 6 a.m. If I have, okay, I can manage my work with 16 plus to 18 GB plus, okay, 2 cores. Okay, but I require, okay, this full strength only during business hours. Yes or no? Why 18 GB 2 cores? 18 GB means 1 driver. Okay, 16 GB plus one executor, 2 GB. Okay, so 18 GB, 1 core, total 2 cores. Okay, see what I'm trying to say here. When you are submitting a Spark job, okay, the number of executors, okay, and all, okay, fixed. Okay, and this Spark job when you start this Spark job, okay, this will be up and running continuously until you stop it. Okay, until you stop it, this 34 GB and 10 cores are dedicated for this job. Okay, but do I really require 34 cores, 34 GB and 10 cores always? If I divide my whole day like this, okay, this is my requirement. I don't want, okay, always 34 GB. Okay, so in this scenario, how much GB I can save? Almost like a 16 GB I can save. Okay, 8 cores I can save. Okay, so savings here, savings. Okay, so savings of, okay, 16 cores plus, okay, 16 GB plus 8 cores. 8 cores, okay. How many hours? 24 minus 9. 15 hours, huh? So 15 hours. Understood. So if I go in this mode, okay, I can save 16 GB plus 8 cores for 15 hours time. Okay, think that, guys. Okay, per core, okay, per hour you are paying, okay, $10. Now tell me how many dollars you can save? Huh? 8 cores, 15 hours. Okay, 15 into each hour, okay, you are saving $10. So per hour, $80 you are saving on 8 cores, and okay, 15 hours. 15 into 80. How many dollars you are saving? $400 you are saving. Are you saving really or not? Yes, you are saving it here. Okay, so Spark has introduced, okay, dynamic memory allocation, sir. Okay, so when you enable dynamic memory allocation here, okay, it works like this actually. Here, okay, you will tell, okay, Spark dynamic allocation equal to true, and okay, minimum executors and maximum executors. You will define these two properties. Okay, when you define these two properties, okay, what will happen? Okay, your driver will be continuously checking what is the load. Okay, whether one executor is able to handle the load or not. If not, it will launch one more executor. If that is okay, if that is also not possible, okay, it will launch one more. Initially, it will start with one. Okay, based on the load, okay, it will be keep on increasing. Okay, maybe okay. So when it reach 9 o'clock, it will reach. Okay, it will launch all the 9 executors. So after 6 p.m., slowly it will reduce one by one, and it may come down to 1. Understood? Okay. So that is called dynamic resource allocation. Okay. When a Spark application is submitted to the cluster allocates the resources requested by application for the entire duration of the application lifecycle. Okay. So these resources are dedicated to that application, but few of the resources will be idle if there are no much load on Spark application, and it's kind of inefficient way of utilizing resources in a cluster. Okay. So to avoid this one, okay, we can enable the dynamic resource allocation. Okay. So here, when you enable the dynamic resource allocation, when the number of waiting tasks are more, okay, Spark application will request for more resources until it is the maximum number of executors. Okay, and when the waiting tasks are 0 or less, okay, it will automatically bring down number of executors. Okay, so this will be taken care by the driver program automatically, but you need to tell in the configuration that so these are the minimum executors I want at any time, and these are the maximum executors I want.
So
Okay.
these, okay, this will be taken care by developer. Yes, sir.
Yes,
Okay.
yes, not by us. Okay. So if you use this, okay, so we can save the resources here. Okay. In the normal mode, okay, so okay. So I will tell you the. Okay, I will tell you this one. Okay. So in this mode, always it will be the same 0. It's on 0% 0 GB. Okay. But okay, when it comes to okay, so this is the without dynamic allocation. Okay, but with dynamic allocation, I can save 16 GB and 8 cores for 15 hours. Any
Sir, I
questions?
have a quick question, sir.
Yes, sir.
Let's say if the file size is 9 GB and the developer is giving 3 executors and with 3 GB each, right? So the file will be stored as an RDD into memory. In the
Yes,
memory,
sir.
the executor is already taking 3 GB, 3 GB, 3 GB. There is no
Yes,
space
sir.
to.
Yes, sir. Okay, sir. Not always. Okay, all Spark jobs will go with always with RDDs, right?
Okay. Okay.
Got it.
Yes,
Okay.
sir.
Some jobs will take RDDs. Okay, not all Spark jobs will have RDDs.
Okay.
Sir, I will give you one example, sir. Okay. Okay. So now I have written a Spark job. Okay, which will fetch a score for you. Okay. Which will fetch a score for you. What is the score? CIBIL score. Okay. Let's say you give your PAN card. It will give you your CIBIL score. For this, what is the input data, sir?
Yeah, very less.
No RDD. Okay.
Yeah.
Because you cannot go and get the PAN card CIBIL data into your Spark job. Okay. So here on the fly, whenever you give your PAN card, okay, your Spark executor will contact CIBIL. Okay, we'll call CIBIL APIs and get the score and give it to you. So nothing is stored in the executor now. On the fly job. Got it?
Sure. Got it. Is there any place where we can see how many executors and how much space it's taking and all that?
Okay. So you can see in the job history server, right? You can open the job history server also. Spark job history server. Okay. Okay. So show incomplete.
So this job history server is same that of MR in
of course, yes, sir. Yes.
Good.
Okay. But there, okay, you can see only MapReduce jobs. Here you can see only Spark jobs. Okay. Which user has started, when he started, all those things. Okay. So you can see the Spark job here. Okay. So this is the Spark job. How many, every time, okay, you execute a task, okay, it will tell you, okay, how many tasks it executed, whether it's successfully completed or not. Okay. All those things. Clear? How many requests each task is performing, all those things will be tracked in the Spark job. Okay, this is about dynamic resource allocation. Okay, now sample integration of Kafka and Spark. Okay, so here we will see. Okay, so this is Kafka. Okay, so this is a Spark streaming job. Okay, what Spark streaming job will do? Spark streaming job, okay, will be continuously checking with the Kafka topic, and whenever there is a new messages in the Kafka topic, it will take the data and give it to Spark Engine. Now Spark Engine will process the data, and finally it will store one copy in HDFS or one copy in RDBMS and one copy it will push to dashboard. Okay, so this is one way. Okay, this is Kafka with Spark. Okay, but okay, let us see Kafka, Storm, and Spark all together in one place. Okay. Okay, when it comes to all together in one place, okay. Yes, okay, I'll give you one simple example where okay, all these three tools are used. Okay. Nowadays, okay, we have a concept of 1 minute loan. I don't know how 1 minute personal loan. Have you ever used? Sorry, have you ever tried?
No, sir.
1 minute personal loan. Huh?
No, sir.
No. Yes, sir. Instant loan. Have you ever seen? Get instant approval in 5 minutes. Okay, forget about 5 minutes. Okay, so personal loan online. Okay, instant loan, instant personal loan online. Okay, so you will get the data. Okay, you will get the data. So here, okay, so click on this one. You will get your, okay, suppose okay, if you are eligible, okay, so you will get your money in your account in 1 minute.
Yeah, like credit card you have, sir. Something like
Not credit card, sir. Okay, okay, even okay, normal also. Okay, you have this thing. Even in credit card also you have the option, right? 1 minute.
Yeah, some new credit card has come. Uni, they give it with it on instantaneously.
Okay, okay. Okay. So normally, okay, you take this one. Okay, so let us take, okay. Let us take this scenario. Okay. If it is only, okay, I'm sure, okay, what I'm showing you now. Okay, so this is the billing. Okay, this is the stores, sir. Okay, these are the Reliance Fresh stores billing machines. Okay, so Kafka chips. Okay, so what these Kafka chips will do? Okay, so Kafka producers. Okay, will be continuously monitoring the billing machines. Whenever the new bill generated, they take this data and give it to Kafka. Correct? Okay, now this is the transaction we made, sir. Okay, transaction. Okay, ID 1 transaction date. Okay, 1st February. Okay, okay. So I will put it like, okay, so 24th of April. Okay, so 24th April. Okay, so this is the data. 24th April. Okay, item soap is 50 rupees. This is the data, actual data in the billing machine. Okay, but okay, when it goes to Kafka, the same thing it will go. Okay, the same thing it will show, like, okay, transaction date. Okay, okay, and okay, or maybe AM. Okay, so here AM. Okay, everything as it is. Okay, so what Kafka producer will do, it will take the transaction from here and put it into Kafka. Okay, now you take Storm. Okay, what Storm will do, Storm will take the same message. Okay, same transaction, and it is converting it, guys. Okay, see how it is converting. Okay, so Spout is taking the same transaction from here and okay, giving it to Bolt. Okay, Bolt is checking, okay, whether this is okay as per the date is fine or not. Okay, and price is fine or not. Okay, there is no minus values in the price, and okay, this is not a old date, this is today's date only. It is checking. Once it is checked, it will pass into next one. Okay, so what this, okay, transformation Bolt it is doing, okay, it is converting the date format. Here it is 24th April, right? It is converting like this. Okay, so okay, 7:45. That's it. See here the date format is like this, but okay, here it is including AM and all here. Okay, but here Okay. So now it removed that AM and PM and all, and it removed the seconds also. It converted this format. 24th April 2022, 2022-04, 24. Okay, this is the format. Okay. So after that, okay, so here, okay, it passed to the next level. Okay, it has given up one more thing like this. Okay, it added Q. Okay, so this is okay, April, right? Q1, quarter one. Okay, it added this one. 2022, 04, 24, okay, quarter one. Okay, now it is storing this final output. Okay, see, this is the original record. This is the original record. But okay, when it is getting stored into SDFS, how it is getting stored, guys? How it is getting stored? It is getting stored like this. Okay, 2022, 04, 24, 745. So the date format is changed. One extra column also added. Okay, quarter equal to 1. Yes or no? So this quarter equal to 1 is purely defined from the transaction date. Which quarter? Quarter 1. Okay. And when it is finally storing this record, it is storing into SDFS like this. Are you clear? Are you clear, guys? Okay. Now you take the same thing with Spark also. What advantage with Spark? Okay, so now, okay, direct Kafka to Spark. Okay, see, earlier it was Storm, okay, but now, okay, you brought Spark here. Okay, so here is the driver. So driver is giving to first executor doing the validation task. Okay, then it is doing the second executor. Okay, and it is doing the transformation task. Okay, now it is going to third executor. It is doing the transformation task. Okay, so finally, what it is doing? Okay, Spark also storing this one copy into CFS, and it is storing it is getting a dashboard also here like this on the fly. Okay, it is telling India. So AP at this moment, this is the sales. Okay, date, it will give you the date also. Date, today's date. Okay, let's say. Okay, this is the 4/20/22. Okay, for this date. Okay, what are the live sales? Understood? Understood, sir. What for this date? Okay, what are the live sales? Okay, it is coming directly. Okay, so Ambani no need to generate any reports and all. Ambani just open this dashboard. Okay, whenever okay somebody purchase any item, immediately this dashboard will change. Okay, let's say in AP. Okay, in AP Reliance Plus store, okay, somebody purchased the item for 100 rupees. Immediately the data will get the data will display like extra 100 rupees. Total will be changed. Okay, India total will be changed. Okay, so like this. Okay, so here okay, you may have grand total also. Understood? One copy in SDFS. Okay, so here grand total. Overall the sales across the world. Super, right? So you can have grand total here. So this is the dashboard, okay, which will be continuously up and running. Okay, so the users, okay, now, okay, easily, okay, these people, okay, can Understood now? So this is a dashboard, okay? Today's dashboard, okay? So Ambani no need to run any query. Anybody does any transaction here, okay? Within fraction of seconds, okay, this dashboard will be updated. Okay, you can see that. If you see this dashboard, okay, you will be seeing the live data. What is the total data? Total transactions per today, total sales per today across globe, 23,49,376. Understood? So this is the advantage with Spark. Understood, guys?
So the advantage is between Spark and Storm is you can see a dashboard.
Also. Got it. Okay, but here there is no dashboard concept. That's the only extra advantage. Okay. Now, okay, we will see. Okay. Okay, now let us talk about the loan process also, guys. Let us talk about loan process. Okay. Normally, what is the loan process, guys? What is the loan process? Okay. So you apply for a loan. Okay. So where you will go and apply for a loan? I will tell you, okay, how people are using technology in our day-to-day life. Okay. So if you want to apply for a loan, okay, normally where you will apply for a loan? Okay, you will go to a bank website, or you will go to bank, or okay, you will call a bank executive. Okay, so what they will do, okay, you will call these people if you want to apply for a loan, and okay, the executive will come and collect all the documents. Okay, executive will come to you, to your home or your office, and okay, he will bring an application form. Okay, he will fill all the details, and okay, so and he will take all the signatures, and okay, so and he will submit this document to loan department. Okay, what loan department people will do? Loan department people will do the first level of verification. Okay, so once you fill all the forms and submit all the documents, okay, then okay, they will call you, sir. We are entering your details into bank site. Okay, so please confirm your mother name. Okay, your date of birth, all the kind of this address and all. Okay, so that's the first level of verification. Okay, then okay, once okay it is done, then we will upload to bank system. Then, okay, so loan department will cut the salary details from the bank. Okay, so now they want to get salary details. Okay, okay, even if you tell, okay, I'm getting 2 lakh rupees per month, okay, they may not believe you. Okay, so they will check from they'll take this deal from the bank directly. Okay, then okay, they'll get the CIBIL score, CIBIL report from government CIBIL site. Okay, then okay, loan department will collect the past loan history from the bank. So see, to give you the loan, they are checking your salary details, they are checking your CIBIL score, they are checking your past history, all those things. Okay, so then okay, so once okay, all these things are done, then okay, loan department will collect the address verification document from executive. So he will send one person for the verification. So one person will come to your home and do the physical verification. Okay, now loan department will upload these proofs in the bank system and send the loan for approval department. Okay, now approval department will check all these details and okay, decide, okay, what is the maximum loan amount can be given, and okay, so they will decide. Okay, so and they'll approve it. Okay, once the amount is approved, the details will be sent to the loan disbursement team. Okay, now loan disbursement team, okay, will deposit the loan amount into your account. Okay, and update the loan records in the banking system. Okay, so this is the process, guys, if you want to apply for a normal loan. Okay, and this will take around 1 to 2 weeks time. Okay, how this process will be taken care by a Spark job in 1 minute. Okay, this is what, okay, sir. Okay, now you see. Okay, so now 1 minute loan process, how it works. Okay, so you will open so in case of 1 minute loan, you will not have executives and all. Okay, you will open the banking website. Okay, you will enter all the details. You will say name is Ravi, is that address Bangalore, PAN card, okay, you will give. Okay, so Aadhaar card you will give, salary 1 lakh, existing loans, okay, MI, loan CMI, okay, 10,000, loan amount I want 5 lakhs, company TCS. This is what he has given. He filled all these details, and okay, he will click on submit. Once you click on submit, Kafka producer will push this message to Kafka topic. This website will have a producer program which will push this message. Okay, this message to Kafka topic. Okay, now Storm Bolt, okay, will receive this message from Kafka topic. Okay, and do the first level data verification. Okay, it will check whether this guy, okay, what is his age? 30 years. Okay, so maybe if the age is more than 50 years, okay, they may not give personal loans. Okay, So such things, okay, they will have some rules they will have, okay, they will check and okay, they will see what is your salary, what is the existing loans. Okay, so if the salary and okay, existing loans, okay, already you have 1 lakh salary, 90,000 existing loans, will they give extra loan? No, right? Okay, so and they will see the company, all those things. So the bold, strong bold, okay, will do the first level of verification. Okay, then okay, so second bolt, once the verification is done, this bolt will pass the data to second bolt. Second bolt will add these details into system. Okay, when it is added into the system, it will generate a application ID. Bolt 1 will generate application ID. Okay, now with these details, it will pass to bolt 2. Okay, what bolt 2 will do? Bolt 2 will do the salary verification, and it will tell whether it is valid or not. Yes, valid. Okay, now okay, once salary verification is done, okay, then it will send it to the bolt 3, which will do the CIBIL website, which will connect to CIBIL website and get the CIBIL score for the same PAN number. Okay, now we got the CIBIL score of 750. It added here. Okay, so this is also valid. Okay, so then it will do the next bolt will do the next level. Okay, it will see the past history, past loan history also, it is valid. Okay, no problems in the past loan histories. Okay, then okay, once this is done, okay, then it will give it to bolt 5. Okay, we'll do the address verification by contacting Aadhaar website. Okay, so nowadays, okay, address verification, they're not coming physically, so whatever is their Aadhaar card, they are taking on the fly. Okay, so now it got the address also. Now bolt 6 will verify all the details and decide the loan amount. Okay, now okay, see, each bolt is doing this one, means the programmer should write these programs. Okay, now bolt 7, okay, will store this completed record in SDFS and hand out the same record to Spark driver. Okay, now Spark driver has the full record. Okay, so which has details like whether loan is approved or rejected. If the loan is approved, okay, executor will request the disbursement system to disburse the loan amount. Then executor will update the bank records in SDFS. So executor 3 will display the loan details applied, okay, approved, disbursed, rejected in the dashboard. Okay, this is the dashboard. Okay, you will see. Okay, so personal dashboard. Okay, and so on to date from this date to this date. Okay, from this date to this date. Okay, so today 1000 applications came, 100 rejected, 900 approved. In this time approved, okay, 600. Okay, maybe for okay. So 890 is already amount is disbursed and is pending. Okay, so this is the dashboard query you can see. Understood, sir? Huh? So this is how okay, your entire loan 1 minute loan process will work. Each executor, okay, each bolt is doing some work. Each executor is doing some work. Okay, finally the loan is getting disbursed into your account. So whatever the manual work we have in the previous step, okay, all those things are automated here. So within 1 minute, okay, you will get your loan. Got it, guys? So technology, okay, see, there are two banks. Okay, one bank is saying that to give personal loan, okay, I need 10 days or 2 weeks. Okay, other bank is saying, okay, I'll give you in 1 minute. Where you prefer? Even though bit interest is high in this bank, okay, you will prefer this one only because okay, nowadays people are not interested to okay wait and get the good things. Even though thing is not that much good, okay, they want it right now. Got it? Okay. So this is how okay. The Spark is here, Kafka is there, Storm is there, Spark is there, everything is there. Okay. So this is a live data processing. Finally, your work is being done. But now you tell me, in this scenario, will you keep anything already available in the executors? Nothing, right? It is on the fly, record is coming, getting processed and stored finally. So here there is no concept of RDDs. Yes or no? In the streaming jobs, okay, you may not be having concept of RDDs. Okay. I guess okay, we spent enough time today, guys. Okay, so tomorrow okay, I will show you okay, maybe the okay, this is what okay, so loan data record processor broker, then okay, Storm everything verification is done at the Storm level, then going to Spark. Okay, so Spark is storing one data in the storage, another thing is in the real-time dashboard. So this is the integration of Spark, Storm, and Spark. Okay, Kafka, Storm, Spark, all three in one place. Clear this?
Okay, sir. Can you share yesterday's recording, sir?
Yes, sir. I will share, sir. Okay. Okay. So tomorrow we'll talk about these things. Okay, and close it. Okay, guys. Thanks for extending your time today.